So let's try to go for some problem on variational principle. So first problem. So I will just try to solve different types of problem where we can use a different concept of this variational principle. And the algorithm of solving the problem is straightforward, simple, but you have to be careful about the finding kinetic energy. You have to be careful about the integration. And yes, the most important thing is when you are going to the final calculation. And I have also give you the trick that you have to write kinetic energy in term of parameter of potential energy. So this is very important thing such that you can compact your final expression and you can solve it. So let's try to go for this particular problem. So what we have, so I have my potential Vx is equal to minus lambda delta x. So this is my potential, Dirac delta potential. So first trial wave function is psi t is nothing but the Gaussian. So I am taking e to the power minus alpha x square. And the second trial wave function is all about, and here x is from minus infinity to plus infinity. And this is cos pi x upon a, where x is between minus a by 2 to plus a by 2. So we have to just try to solve this particular problem with two different trial wave function, and we also try to find which one of the following trial wave function is much better trial wave function. And we know that exact trial wave function, and this is minus sign, so this will be minus sign. So exact wave function for this is basically e to the power minus alpha x, or you can, that is minus mod x. We have solved in our when we have solved the Schrodinger wave equation. So we know all these particular calculations. So let's try to go for this. So let's go for first trial wave function. So obviously, so my normalized trial wave function is equal to 2 alpha upon pi to the power 1 by 4 e to the power minus alpha x square, where x is between minus infinity to plus infinity. And obviously, we have our kinetic energy. And what is kinetic energy here? The kinetic energy is h cut square alpha by 2m. So this is very famous trial wave function, Gaussian wave function. So this is my kinetic energy. Okay. Now we have to find the potential energy for this particular trial wave function. So when we are going to find the potential energy for this particular trial wave function, then obviously we have to calculate the potential energy. I am using this space actually. So the potential energy V is given by, obviously we have to go from minus infinity to plus infinity. And the potential is Dirac delta, that with the negative sign, that is attractive Dirac delta. So minus lambda delta x, and we have 2 alpha to the power pi to the power 1 by 2 e to the power minus 2 alpha x square dx. So this is my potential energy. So you just use this expression actually. The potential energy is all about psi star Vx psi dx, minus infinity to plus infinity, and finally you will get this one. So, and this is your potential, and this is mod psi square. So when you have this particular thing, you have 2 alpha by pi to the power 1 by 2 minus lambda we can take outside from integration. And here we have minus infinity to plus infinity e to the power minus 2 alpha x square dx. So what is this particular integration? And sorry, minus delta x is also, and sorry, delta x dx is also there. So what is this particular integration?
1.
Obviously, delta x is equal to 0, we have delta, and minus infinity to plus infinity. So you will put x is equal to 0 for this particular function, then this is 1. So we have minus 2 by pi, minus lambda to the power pi to the power half, and alpha to the power half. So this is our expectation value of potential energy. So when we will go for the average value of total energy. The average value of total energy is h cut square alpha upon 2m minus lambda 2 upon pi to the power half will be there. This is constant. My parameter is alpha in this particular expression. Now, next thing what we have to do, we have to just go for a basic differentiation. We have to find the value of alpha for which this energy is minimum. So what we have to do, we have to just go for dE upon d alpha must be equal to 0. And from there, we can have h cut square upon 2m minus lambda 2 by pi to the power half, and that will be half alpha minus half. Am I correct? ठीक लिखा हूं ना? Okay. And from here, we can find the value of alpha. But before that, we can write our kinetic energy as a parameter of potential energy. And this must be equal to 0. So from here, we can write this expression as h cut square upon 2m is equal to lambda 2 upon pi to the power half, and 1 by 2 is also there. Alpha to the power minus half is there. So we will multiply for writing the kinetic energy. We will multiply this by alpha. So we have to also multiply this by alpha. So this is my kinetic energy. And I can write my kinetic energy as, so I can write my kinetic energy as a parameter used in potential energy is basically lambda by 2 to the power half and alpha to the power half. And when we will put this equation here, so this is my kinetic energy, and this is equivalent to actually h cut square alpha upon 2m. So यहाँ जब आप इसे put करोगे, then what you will get? Then you will get your energy is minus lambda by 2, and this lambda by 2 is also there, na? So lambda by 2 is also there. So minus lambda by 2, and you will get this thing 2 by pi to the power half and alpha to the power half. Isn't it? सही लिखा हो ना? So this is your average value of energy. This is your average value of energy. So from here, you need not to calculate value of alpha. You have to calculate value of alpha to the power half. That is the smart move from there. Because once you will put the value of alpha, and then again you will put the value of alpha by half here, then it may be that there is chance of error. So when you are using this concept, using this trick, then what you will do, you will have less chance to error. Okay? So यहाँ तक clear है ना, everyone?
Yes, sir.
Okay. So let's try to go for final value. So I am removing this one. So from there, what I have average value of E is equal to minus lambda by 2 and 2 by pi to the power half, and we have alpha to the power half. And from there, I can find alpha to the power half. So what is alpha to the power half here from this equation? From there, we can find the alpha to the power half, isn't it? So we have, so I will remove this part also. And then we can calculate it easily. So we have h cut square upon 2m, that must equal to lambda 2 by pi to the power half, lambda by 2 alpha to the power minus half. When we will take it here, then this value is alpha to the power half, and we will get lambda by 2 by pi to the power half, and here we have 2m upon h cut square. Yes, so I will put this value here. So what I will get? So I will get minus lambda by 2 by pi to the power half, and lambda to the power half, again I will get lambda by 2 by pi to the power half as well as 2m upon h cut square. And from there, we can get the final solution. So what is your final solution? So that value is basically minus lambda square. This 2 is 4. And this will be exactly same thing. So 2 by pi. And we have 2m upon h cut square. So yes, this 2, and this will cancel out. And we have minus lambda square m upon pi h cut square. So this is your approximated energy. This is your approximated energy minus lambda square m upon pi h cut square. Isn't it? What is the exact solution, exact answer? Anybody remember that answer? किसी को याद है? Yes? हमने डिराक डेल्टा किया है ना? कंप्लीटली सॉल्व किया है डिराक डेल्टा. किसी को याद है ये? सॉरी? नो. आप अपनी कॉपी में जाकर के रिवाइज करोगे आज ही डिराक डेल्टा. When your wave function is e to the power minus alpha mod x, then this pi will replace by 2h cut square. Okay, just go and revise your Dirac delta at today itself, so that you can do the revision also. So that will be 2, but here is 3.14. So which one is greater, that or this one? This one, because negative sign is there, isn't it? So that will be in the upper level, okay, towards the 0, है ना? Are you getting my point? अगर आप energy level लिखोगे, the negative energy is this one and this one. So if this is your actual value, then this is your some next level of value. Okay, so you can have that energy line. Okay, anyway, so this is your correct answer when you are using Gaussian wave function. Let's try to use another wave function for the same potential, such that we can compare also. So when we are going to use the next wave function is your cos pi x by a. So let's try to go for again my Vx is equal to minus lambda delta x. And what is our psi x? Psi x is equal to a cos pi x by a, and x is between minus a by 2 to plus a by 2 and 0 otherwise. So if this is my wave function, then we have to find what will be ground state energy. So this is an approximate wave function for the ground state. So first we have to write the size and normalized form. What will be normalization constant here? That will be nothing but 2 by a cos pi x by a, where x is between minus a by 2 to plus a by 2, isn't it? And 0 otherwise. And 0 otherwise. So from there, you can find the kinetic energy. What will be kinetic energy? This is very simple. What is kinetic energy here? Average of kinetic energy on this particular wave function? So h cut square pi square upon 2 ma square. है ना? H cut square pi square upon 2 ma square. This is our kinetic energy. Let's try to go for potential energy. When we are going for potential energy, again we have to go from minus infinity to plus infinity, psi star Vx psi dx. And when we will go for this, so we have to go for minus a by 2 to plus a by 2. 2 by a is my normalization constant when we will take the mod psi square. And here we have minus lambda I can put from potential, and that value is delta x, and this value is cos square pi x by a dx. Okay, so this is your wave average of potential energy. What is this value? What is this value? क्या होगा इसका value? X की जगह पर क्या put करोगे?
So 0 put
0.
करेंगे.
So that value is again 1. So average value of potential is minus 2 lambda by A. Now, what is my average value of energy? The average value of energy is average value of kinetic energy plus average value of potential energy. And here you have h cat square pi square upon 2ma square minus 2 lambda by A. Now, can you please tell me what is parameter here? क्या parameter है?
M and A.
Sorry?
A.
A is the
A.
parameter, okay? So don't be confused कि हमेशा अल्फा ही दिया रहेगा. So parameter is used in a wave function. So you have to careful about that thing. Okay? So this is your average value of energy. So for the minimum value of energy, we have to find the suitable value of A. So how we will get the suitable value of A? That we can easily go for D expectation value of E by dA must be equal to 0. And from there, we can have h cat square pi square 2ma is ma cube and minus 2 is also there. ठीक है ना? And this value is minus plus 2 lambda by a square must be 0. यहां से बताओ अब क्या क्या निकालना होगा हमें. First we have to write kinetic energy in term of what? Potential energy.
Potential energy.
है ना? सबसे पहला काम ये कर लेंगे तो हम देखेंगे हमें क्या करना है. ओके?
सर हम पैरामीटर फिक्स्ड क्वांटिटी को ले रहे हैं ना.
पैरामीटर वो हम ले रहे हैं जो वेव फंक्शन में हम यूज कर रहे हैं. दैट इज नॉट फिक्स क्वांटिटी. ओके?
ओके सर.
वेव फंक्शन में दो ही चीज तो होगा. एक x होगा, वेरिएबल होगा, और जो कांस्टेंट होगा. यहां हम कांस्टेंट को भी चेंज करके देख रहे हैं. आर यू गेटिंग माय पॉइंट?
यस सर.
है ना कि कौन सा a जो है जो हमें मिनिमम एनर्जी देगा. आर यू गेटिंग दिस थिंग फॉर दिस पर्टिकुलर पोटेंशियल. सो कहने को तो वो पैरामीटर है एक्ट और एंड पैरामीटर इन जनरल इज फिक्स. बट हम क्या कर रहे हैं? वी आर द चेंजिंग द पैरामीटर एवरी डे. मतलब एवरी टाइम, नॉट एवरी डे, एवरी टाइम. And we see that which parameter will give you the correct answer.
Yes,
और
sir.
ये पैरामीटर के ऊपर जो आप वर्कआउट करते हो सबसे ज्यादा कहां करते हो? कभी कुछ है पता? एक पर्टिकुलर टॉपिक में आप देखोगे पैरामीटर के ऊपर ही वर्कआउट करोगे. कौन सा टॉपिक है? इज दैट पुनीत इज देयर? है? नहीं है?
हाँ
चलो
सर.
है वो? बताओ पुनीत, कहां किस टॉपिक में पैरामीटर पर हम ज्यादा काम करते हैं?
सर अभी क्लिक नहीं कर रहा है सर. तो moment.
एनीवन? किशोर इज देयर? श्री लक्ष्मी इज देयर? कोई नहीं.
Yes, sir.
So where you are using the parameter and you can vary the parameter every time. कहां पर यूज करते हो इसको? In which topic? Very important topic. Whole topic is based on this. No?
सर
Guess. चलो हिंट देता हूं. इलेक्ट्रोमैग्नेटिक थ्योरी, क्लासिकल मैकेनिक्स, क्वांटम मैकेनिक्स एंड स्टैटिस्टिकल मैकेनिक्स. Which option is correct? हाँ?
सर क्लासिकल मैकेनिक्स इसमें थीटा वगैरह चेंज करते हैं.
थीटा इज वेरिएबल. पैरामीटर पर आप काम नहीं करते हो. स्टैटिस्टिकल मैकेनिक्स, एग्जैक्टली. अभी जब आपकी स्टैटिस्टिकल मैकेनिक्स शुरू होगी तो आप देखना जो आप बेसिकली पार्टीशन फंक्शन बनाते हो और पार्टीशन फंक्शन में आप पैरामीटर के ऊपर खेलते हो. इजंट इट?
यस सर.
भाई आप इंटीग्रेट किसके साथ करते हो? एक्स और पी एक्स के साथ इंटीग्रेट करते हो. इजंट इट?
Yes, sir.
तो जैसे ही इंटीग्रेशन करते हो तो खत्म हो जाता है, वेरिएबल इज गॉन, इजंट इट? और आप पैरामीटर के ऊपर सारा काम करते हो. तो statistical mechanics is a wonderful topic where we work with the varying the parameter and we can see what is going to happen. Yes, so this is very important, है ना? And obviously in quantum mechanics too. Okay, so let's try to go for this. So what we have pi square h cut square upon 2m a cube, and minus 2 is there when it will go there, so 2 is there, and you have 2 lambda upon a square. So I can multiply with a here, I can multiply with a here, I have to divide with 2 here, I have to divide with 2 here, then I will get pi square h cut square upon 2m a square, which is nothing but the my kinetic energy, and this value is what? Lambda upon a. ठीक है ना? And what is my energy? My energy is nothing but lambda upon a minus 2 lambda upon a, that is minus lambda upon a. अब यहां बताओ हमें क्या निकाल लेना चाहिए? 1 by a की वैल्यू, है ना?
Yes, sir.
We have to calculate the value of 1 by a. तो यहीं से आपको पता चल जा रहा है हमें क्या निकालना है. ओके, सो व्हाट यू कैन टेक, यू कैन टेक 1 by a square common, and you have h cut square pi square upon 2ma minus, or you can say minus here, plus 2 lambda must be equal to 0. And from here we can get a cannot be infinity because they have to be some constant value. So from here we can get value of 1 by a. What is 1 by a? So 2 lambda is there. So 4 lambda upon m upon h cut square pi square. So we will put this particular value here. So the average value of energy, which is minimum energy, and that value is minus lambda into 4 lambda m, and we have h cut square pi square. What is this value? So this value is minus 4 lambda square m upon pi square h cut square. So from there are two particular wave function. Which wave function is good wave function for this particular system? Gaussian or cos wave function?
Caution.
किसकी वैल्यू ज्यादा है?
सर एनर्जी के मामले में ये
Obviously lambda square m and h cut square is common in both. वहां पर क्या था? 1 upon pi, isn't it? और यहां पर क्या है? 4 upon pi square. So कौन सा ज्यादा है?
ये वाला ज्यादा.
ये वाला ज्यादा है. So obviously that will be the better one. Now you can just check this number. Okay? So हाँ बताओ.
लैम्डा स्क्वायर आएगा.
क्या हुआ?
सर वहां पे 2 कैंसिल भी होएगा ना?
क्या कैंसिल होगा?
सर 2.
अरे 1 by a की वैल्यू निकालो ना यहाँ से. ये नहीं आ रहा है 1 by a की वैल्यू. Yes या no? Yes? Okay, एक 2 भी है ना? Okay, sorry. You are correct. So there is 1, 2 is also there. ये 2 हम लोग मिस कर रहे हैं. 1, 2 is there, so you can find 1 by a के लिए आप 2 भी यहाँ पर रहेगा. Sorry.
No,
so 1 by a is 2. 2 is here, na? Sorry. That
Yes.
value is 2 is here. So you can put here, then this value is 2 here and 2 is here. Then it's okay? ठीक है?
Yes, sir.
है ना? Good. Thank you. So then 2 is here. वहां पर मैं 2 मिस कर गया था. So obviously, so just check the calculation, है ना? You can check the final calculation, and that value is minus 2 lambda square m by pi square h cut square. So you can just check which one is the greater and which one is the lesser. So जिसका कम होगा वो better wave function है. Okay? Let's try to go for a very tricky question. ये तो स्ट्रेट फॉरवर्ड क्वेश्चन है, आपको एवरेज वैल्यू निकालना चाहिए और आप इजिली निकाल पाओगे. लेट्स गो फॉर दिस ट्रिकी क्वेश्चन. मे बी दिस टाइप ऑफ क्वेश्चन कैन केम इनटू योर एग्जाम. Let's try to go for this. And this is really very wonderful if you can try to solve this problem in a very efficient way. Okay, so I have Vx is equal to K mod X. So this is this particular potential. Okay, Vx versus X. And trial wave function for ground state. Trial wave function for ground state. So for ground state is a cos pi x upon a, where x is between minus a by 2 to plus a by 2 and 0 otherwise. This is very interesting. So this is a trial wave function for the ground state. You can just write your psi. Okay, psi x. But my question is entirely different. Using method of variational principle, method of variation, find energy of first excited state. This is very interesting. If examiner will smart, then they have to give this type of problem. Because यहां पर फिर आपको ट्रायल वेव फंक्शन चूज भी करना पड़ेगा. Isn't it? Because this trial wave function is for what? For ground state. And what you have to do? You have to just calculate the energy for first excited state. This is very interesting. Then obviously, you have to first choose the trial wave function that should be mainly associated to this particular wave function, such as this is ground wave function. And then you have to use the variational method of principle. Is that question में दम है या नहीं?
Yes, sir.
है ना? आज ही मैंने इसे निकाला है. ठीक है? बहुत समय से मैं इस तरह के प्रॉब्लम फॉर्म करने की कोशिश कर रहा. So finally I get one. कैसे होगा पुनीत बाबू, बताइए. Anyone. So let's open discussion. How you will choose trial wave function just after viewing or analyzing the ground state trial wave function. Then how you will go for first excited state trial wave function. This is very interesting.
So the first state is so the first state ground state, so that's like symmetrical. So the second वाला होगा वो ऐसा हमें चूज करने की कोशिश करना चाहिए थोड़ा सा एंटी सिमेट्रिक हो, यानी कि psi minus x equal to minus psi x nature.
Good. Basically, if you want to analyze the thing, then if your first ground state is given, then you have to choose that wave function which will be orthogonal to first one, isn't it?
Yes, sir.
So हमें एक ऐसा wave function choose करना पड़ेगा जो orthogonal हो first one के, and obviously it should be normalized also. सो अगर आप ये ट्रायल वेव फंक्शन देख रहे हो तो ये ट्रायल वेव फंक्शन किसका एग्जैक्ट वेव फंक्शन है?
सर इनफाइनाइट सिमेट्रिक पोटेंशियल
इन्फिनाइट सिमेट्रिक पोटेंशियल के लिए, रिमेंबर? तो देखो हम लोग पुराना भी रिवाइज करते जा रहे हैं. So this is for the infinite symmetric wave function from the minus a by 2 to plus a by 2, and this is my ground state, and this value is equal to 2 by a cos pi x by a. So what will be my first excited state trial wave function?
सर √2 by a
Huh?
sin 2 pi x by a.
Very good, very good. So first excited state is something like this, and this will be √2 by a sine 2 pi x by a between minus a by 2 to plus a by 2. So your trial wave function in this particular problem is not cos pi x by a, rather this is trial wave function is something normalized trial wave function. You can take √2 by a sine 2 pi x by a, where x is between minus a by 2 to plus a by 2. अगर सपोज करो ट्रायल वेव फंक्शन आपका रहता a e to the power minus alpha x square for the ground state. So what will be trial wave function for first excited state? क्या होता?
सर a x e to
Very
the
good.
power
So
minus
then
alpha
your
x.
trial wave function is something b x e to the power minus alpha x square. Remember, you have intuition from harmonic oscillator here. So why those 3 and 4's problem, harmonic oscillator, particle in a box, hydrogen atom, Dirac delta potential, are very important. Because once you know that particular system, you can analyze any complicated system. And it is very difficult to calculate the energy eigenvalue for this particular potential from using the Schrodinger wave equation. Yes, you can solve it, but it will take a lot of pain to calculating that thing. And here we can use our intuition and we can easily solve this particular problem. Are you people happy? So
Yes,
let's work on this beautiful problem, है ना? ये एक ऐसा क्वेश्चन है जो कि एग्जाम में आना चाहिए और इसमें ऑब्वियसली स्मार्टनेस पता चलेगी स्टूडेंट्स की, है ना? सो और देखो इंटीग्रेशन हम कितना मजेदार ढंग से करेंगे, वो भी बड़ा मजेदार है. एनीवे, व्हाट विल बी योर काइनेटिक एनर्जी नाउ? एवरेज ऑफ काइनेटिक एनर्जी, एनीवन?
so 4 pi square h square by 2m square.
So that value is 4 pi square h square upon 2m square. Okay, and then we have to go for average value of potential energy. When we are going for average value of potential energy, we have to go for psi star Vx psi x dx from minus infinity to plus infinity. But here we will go for minus a by 2 to plus a by 2, and you have mod x k, and that value is equal to 2 by a sine square 2 pi x upon a dx, isn't it? Can I write this integration as 2 a 0 to a by 2 time x sine square 2 pi x by a dx? लिख सकते क्या?
Yes, sir.
Mod x is even function, isn't it? What is meaning of mod x? Meaning of mod x is basically root under x square. So you have plus x and minus x. When x is between 0 to infinity, you have plus x. When x is less than 0, you have minus x. So I can use this integration easily. Now you can do this integration very nicely, but I will do this integration in a different way. So I have intuition of particle in box, and that is 4k by a is there. And just write this way. So 2 is there, k is there. So 2 by a I will take here. And integration 0 to a by 2 x sin square 2 pi x by a dx. क्या होगा इसका इंटीग्रेशन? एनीवन?
हाँ सर, किया तो नहीं, पर आई गेस 3/4 हो सकता है पॉसिबल।
अगर आप इसको देखोगे तो आप इसको ऐसे बना सकते हो 0 to a by 2 x sin स्क्वायर पाई x a by 2 dx लिख सकते हो?
यस सर।
लिख सकते हो, है ना? एंड 2k एंड 2 by a को ऐसे ही रहने देते हैं, एंड वी कैन मल्टीप्लाई 2 by a by 2, then so I can multiply by 2 here, then I can divide by 2 here also, है ना? Yes or no?
यस सर।
Yes. So I can have k, this 2 and 2 cancel, 2 by a by 2 integration 0 to a by 2 x sin square pi x a by 2 dx. What is this value?
It's like infinite box problem, but from 0 to a by 2. So
Exactly.
infinite
This is expectation value of x in a ground state for the 0 to a by 2. So what
So
will be
a
average
by
value?
4. A by 4.
A by 4. That value is k by 4. Isn't it?
Yes sir.
सही है? हाँ?
Yes
Now
sir.
you can try
Yes
it
sir.
with your integration equipment. आप इसे try करो, but I have calculated like this, है ना? So I can use my quantum mechanical knowledge to solve this particular. So this is nothing but Ka by 4. So this is my potential energy. So this is my potential energy and that is Ka by 4. So let's try to go for ये integration समझ में आया ना? Okay. So let's try to
Yes,
go
sir.
for this one. So we have total energy, that value is equal to 4 pi square h cat square upon 2ma square plus Ka by 4. What is your parameter here? Again, A is your parameter. So you have dE upon dA must be equal to 0. And what do you have? You have again minus 4 pi square h cat square 2m a cube, and you have minus 2 is here plus k by 4 is equal to 0. What is your next step? क्या करोगे?
Writing kinetic energy.
Writing kinetic energy in term of potential energy. So you have 4 pi square h cat square upon 2m a cube must be equal to k by 4. 2 is there. So first I will divide by 2. I will divide by 2. I will multiply by a. I will multiply by a. Then we have 4 pi square h cat square upon 2ma square is equal to Ka by 8. Isn't it?
Yes sir.
So this is my kinetic energy as a parameter of potential energy. So my total energy is, the total energy is basically Ka by 8 plus Ka by 4, and we have 3 Ka by 8. Isn't it? और यहां से हम किसकी वैल्यू निकालेंगे? A की वैल्यू निकालेंगे, है ना? Because this is function of A. So we will use this one. So from there we can have 4 pi square h cat square upon m a cube. this 2 and this 2 is cancel out, must be equal to k by 4. Negative negative is cancel out. So a to the power cube is 16 pi square h cut square upon mk. So what is value of a? This implies a is equal to 16 pi square h cut square mk to the power 1 by 3, isn't it? So we will put this particular value, and we have 3 upon 8 k into 16 pi square h cut square upon mk to the power 1 by 3. Now you can take k inside, 3 inside, 8 inside, and you can manipulate what will be your final answer in a very compact form. Okay? So k को अंदर
Yes,
ले
sir.
जाओगे तो क्या हो जाएगा? k क्यूब. 3 को अंदर ले जाओगे 3 क्यूब. 8 को अंदर ले जाओगे 8 क्यूब, and you can just cut all this thing. Then you can easily calculate one. है ना? हो जाएगा ये?
Yes, sir.
है ना? एग्जाम में ये सब थोड़ा करना पड़ेगा. So इसकी प्रैक्टिस आप अच्छे से करोगे. 1 by 3 है तो ये 3 क्यूब, 8 क्यूब. तो फिर बाकी सारे चीज कैंसिल होते जाएंगे. ठीक है? So obviously this type of problem can came into your exam if some smart people will set the questions. Otherwise they will just ask the straightforward question. ठीक है? So now I will request you that next 2 and 3 day just go and do the tutorial of this particular topic. Okay? And we have beautiful questions in your tutorial. So it is very important that you should involve yourself, and then I will take one more class for this. But before that, just try to solve the tutorial, because calculation is very important. Then I will take some more new questions in the next class. But before that, you should go for tutorial. It will take at least 3 to 4 hours to calculate all this thing. Okay?
Yes, sir.
Yes?
जो राइट मोस्ट बॉटम पे आपने एक एक्सप्रेशन लिखा है ka/8 इज इक्वल्स टू पाई स्क्वायर h कट स्क्वायर, राइट में सबसे नीचे
ये
हम डायरेक्टली ka/8 की वैल्यू को भी तो यूज कर सकते थे ना, एक्सपेक्टेशन वैल्यू।
अरे नहीं ना, बेसिकली हमें के के टर्म में सारा लिखना है ना. अच्छा, उसे यूज करके देख लो क्या आता है. के का तो रहना ही है, के को आप हटाना नहीं है आपको. ओके, वेरी गुड, वेरी गुड. You have to give the answer in term of k, because k is given in potential. Are you getting my point?
यस सर।
So each and everything you have to write in term of k. You have to remove the term which is in the wave function. Okay? यहाँ नॉन तुम्हें क्या है? नॉन तुम्हें k है. वेरिएबल क्या है? x है. x तो खत्म हो गया इंटीग्रेशन के बाद. तो आपके पास नॉन क्या रहा? जो पोटेंशियल के अंदर वेरिएबल है वही तो नॉन रहा.
यस।
एंड मास एंड ऑल दिस थिंग. रिमेंबर दिस थिंग. तुम देख लो सारे प्रॉब्लम को. हमने हार्मोनिक ऑसिलेटर सॉल्व किया. आंसर किसके टर्म में आया? ओमेगा के टर्म में. दिस इज योर वेरिएबल. दिस इज योर कांस्टेंट यूज इन पोटेंशियल. देखो ध्यान से. डिराक डेल्टा को दो तरीके से सॉल्व किया. दोनों में आंसर किसके टर्म में आया? लैम्डा के टर्म में. Yes or no?
Yes, sir.
Yes.
Yes, sir.
And here you are solving this particular k mod x. आंसर किसके टर्म में आ रहा है? k के टर्म में.
K के टर्म.
तो k को आपको हटाना नहीं है. ठीक है?
Yes, sir.
है ना? ये हमेशा m और h तो बहुत यूनिवर्सल है क्वांटम मैकेनिक्स के लिए. मास तो होगा ही, h कट तो होगा ही होगा. बट उसके अलावा जो कांस्टेंट होगा दैट शुड बी फ्रॉम द k, फ्रॉम द पोटेंशियल एनर्जी. ठीक है?
Yes, sir.
ओके, सो डोंट डू दिस टाइप ऑफ ब्लंडर. है ना? कि k को ही हटा दिया. ओके?
Yes, sir.
Okay, chalo. So I think we must stop here. So please solve that tutorial into your booklet. उसे जरूर सॉल्व करो. उससे ज्यादा बेटर प्रॉब्लम कहीं नहीं दिए हुए हैं. ऑल जितने भी प्रॉब्लम है, प्लस मैंने खुद कुछ प्रॉब्लम बनाया है, सबको हमने उसके अंदर इंक्लूड किया है. एंड देन आई विल सॉल्व वन और टू मोर प्रॉब्लम into after you have solved it, and then we will go for next topic. ठीक है? Thank you.
Thank you, sir.